Okay, so in paper, in fact, yes, in paper 2, we have discovered with the working of the stack, and we saw how basically it's just it was just an array basically, and but the algorithm of working of stacks allows elements to be added uh, in an array using your first in first out principle. So what that means is that last in first out, principle. So what that means is that the elements that are pushed in the element first will move towards the bottom of the stack, and any element that is pushed in last will be the first to remove, first to leave the stack. Essentially, there is no choice as to what element you can remove. The only option that you have is that you can remove the element at the top. Uh, as for the working of the stack, this index position is known as the base of stack pointer. This pointer is not going to be moving ever. The base will not be changing. However, the top of stack pointer will be moving according to the elements that are either pushed and popped from the array. Again, this which brings us to the two operations that are allowed for your stack. You can either push an element in an array or you can pop it. So by the way, pushing means that you simply add it on the top of the stack. And if a pushing step takes place, your top of stack pointer will be incrementing, pointing towards one step ahead. And if a pop operation takes place, what that means is that the top of stack pointer will come down one place, pointing towards the one element below. So basically, at the top of the element has now left the array, and my top of stack pointer has shifted one place now. And if my array is empty, that means, or my stack is empty, basically what we're looking at is my top of stack pointer have the value -1. And if you remember, we've already discussed that if we're using zero index position as part of our array, our null will be considered as -1. So in that case, that's what's happening over here. Our null is -1. So anyway, note that base of stack pointer will always remain at point at the element 0, and the top of stack pointer will vary based on what's happening to the array. It will increase when an item is pushed onto the stack, and it will decrease when an item is popped off the stack. When the stack is empty, stack pointer will have the value -1, so on and so forth. Okay, now let's check out what's happening with respect to creating a new stack. Okay, it's mentioned here -1 because when index position 0 is being used, so null is -1. Okay, we have three constant. Empty string is assigned with the empty string and it's constant. Null pointer will be assigned with -1, and constant max stack size will be 8. So basically that means my size of stack will be of 8 elements. Okay, now what happening here is that I'm declaring two variables here: base of stack pointer of type integer, top of stack pointer of type integer, so on and so forth. Declare stack, which is an array starting from index position 1 to max stack size -1 of type string. Okay, now here's where one thing that I think something is wrong over here. So basically, this should not be starting from 1. This should be starting from 0, because as you remember, the declaration of an array that we studied before states that the array is declared in this way, that we got declare the name of the array, this array keyword, and the index position ranges that will exist. So this states that index position 1 is the starting point, and all the way leaving to index position 7. So that means that I am not using index position 0, even though index position 0 is part of my array. So I think there's a slight mistake here, and what it really should be is, let me add here. What it should say here is that it should say declare stack array index position 0 to max stack size -1 as of type string, like so. So that's really what this line should be. Instead of starting from 1, it should be starting from 0. So I guess this is slight mistake here, but that's okay. Happens. So anyway, so that's my declaration. We will not be using this. This is not to be used. We use this statement over here. Okay. Now, afterwards, this is the procedure for initializing a stack. So basically what that means is that I have declared an array. There's nothing of it. It has a type string and yet there's no data in it. So since I'm starting to add data for the first time, that means I will be calling the initialize procedure. And for initialize procedure, this is what's going to happen. My base of stack pointer will be assigned 0, and my top of stack pointer will be pointing towards, will have the value null in it. Base of stack pointer, remember I said that it will not change. So it will remain 0. And as you can see here, it's not meant to change, it won't change. However, the top of stack pointer, since it has no elements right now, it will have the value null in it. So after each subsequent addition, the top of stack pointer will increment. So that's what's happening over here. Now let's discover the procedure for pushing. As mentioned before, there are 2 steps. There are 2 operations that can be taken, that can be handled using stacks. One is the push operation, in which we're adding an element to the stack, and one is the pop operation, in which would removing elements from a stack. So let's check out the push operation. If top of stack pointer is less than the max stack size. So basically what this means is that if my top of stack pointer is at 7, by the way, that's my max stack size. So what that means is that if my top of stack pointer is at 7, what that means is that all of my array is filled. It's full, and there is no more room in my array. In which case, if that condition is false, if this condition is false, there is no room in the array, and I cannot push elements any further in my stack. So I have to check if this condition is true. If this condition is true, and my top of stack pointer is here somewhere, that means that I still have room to push an elements in my array. However, if my top of stack pointer has reached here at position 7, it is no longer lesser than my max stack size, which is also 7. In which case, I will exit the loop, and there's no more room I can add to it. Anyway, so as long as my max size top of stack pointer is less than max stack size, 8 minus 7 is lesser than 8. If top of stack pointer is lesser than 7, it's lesser than 7, that means I still have room to add elements. So if my top of stack pointer has reached index position 7, that means this condition will no longer be true, and I will no longer be able to add any more elements to my stack. So I have to check if there is room in the array or not. However, if this condition is true, only then I will move towards the next part. Okay, so what happens here is I will proceed towards first incrementing to the new place, in which top of stack pointer is now incremented. So if my top of stack pointer in this case, for example, is at 3, I'm pushing a new element on the stack. So for example, A, B, C, D, I'm trying to add E here, in which case E will end up here, and my top of stack pointer will now, first I have to increment the top of stack pointer, and my top of stack pointer will now be pointing towards index position 4. How? Top of stack pointer plus 1 assigned to top of stack pointer. So my top of stack pointer would be previously was 3, now it's pointing towards 4. And after that, now since the top of stack is pointing towards 4, I will simply access the stack array at this place, which is 4, and add the new item there. So my E is assigned to the new place. And that's the end of this push procedure. Simple as that. Focusing on the popping, pop means that we simply remove an element that is located on the top of the array. So basically what that means is that I will in a way somehow delete this index position. We'll look at how that's being done. And afterwards, I'll have to decrement my top of stack pointer to come down to point this at this position as the top of my stack pointer. So let's see how that's being handled. Anyway, first of all, I will have to declare, and by the way, popping means that it's going to return something. So I need a variable in this subroutine, a local variable. We're going to call it item of type string. Item is initialized with an empty string. By the way, as you remember, that empty string is a constant. Empty string is a constant which has an empty string in it, by the way. So we assigned the item with an empty string essentially. If top of stack pointer is greater than null pointer, so that basically means that if top of stack pointer has null in it, that means there's nothing in the array. What are you going to pop? There's nothing to pop. So there has to be at least one item. There has to be at least one item in my stack to be popping. So in fact, to check for that, I am simply making a comparison that is my top of stack pointer greater than my null pointer. If that is the case, then there is at least one item in my array to pop. So if this condition is true, only then this pop routine will carry out. So what's happening in the pop routine? I will simply take the current stop element at the top. Current element at the top means that I have the top of stack pointer, which is pointing at the current element, the topmost element. I access that element at this position in my stack array, and I will move that element to this variable item. After that, I will decrement my top of stack pointer to point one place below it. And afterwards, I will simply return the item that I just assigned from that previously top of stack pointer. So basically, this is the effect of popping an element. Okay, by the way, I forgot to mention this. For the push subroutine, I have to take a parameter of the element that you want to add to this stack. So the user will enter the element that, for example, we wanted to add E to this stack over here. We want to add E to the stack. So we'll basically pass E to this push procedure, and that new item will be added to the top of stack pointer position after it has incremented to the new top of stack pointer. Similarly, if we want to pop the element, since this is a function, this was a procedure, this is a function, it means it's going to return something. So by that logic, I will simply first of all access that top stack pointer position, and I will assign that value to this item variable that we just declared locally. I will return that item and decrement the top of stack pointer to point one place below that. So these are the two operations that are handled through in a stack. These are push subroutine, and this is the pop subroutine.